Hey guys, Mr. Creed here, back again with another video. Hope you guys have had a great spring break. I know you guys probably enjoy the time to sleep or play Xbox, PS4, or catch up with your friends through FaceTime, whatever, or even possibly watch Netflix. New big hit right now is Tiger King. I would not recommend that. I will not do a review video, but I would definitely not recommend watching that because it's just honestly it's pretty dumb. Uh, Nevertheless, we're going to get back today talking about independent and dependent events. We're going to wrap up this unit with these two topics here. Okay. So the first video we're going to talk about is independent events. Okay. Let's start with this by doing a review of multiplying fractions. Okay, because you're going to be seeing this here in a few moments. All right. So multiplying fractions, we just multiply um, pretty much across. We do top times top and bottom times bottom. Okay, so as you can see, I've done this all the way across here. And 1 times 3 is 3, 2 times 4 is 8. So that becomes 3/8. You cannot simplify that. That's as far as it goes. Okay. All right, so we got 1/8 times 4/5. Again, multiplying fractions, just multiply top times top, bottom times bottom. 1 times 4 is 4, 8 times 5 is 40. Okay, I do want you to simplify this. Okay, a common factor that 4 and 40 share is going to be 4. So if I divide top and bottom by 4, I get this right here, 1/10. Okay, this is equivalent to 4/40. All right, so we got 2/9 and 3/5. 2/9 times 3/5. This will give us 6/45. Well, look at this first glance. You probably would not think that there would be a common factor that 6 and 45 would share, but that is not the case. 6 and 45 do share a factor of 3. Okay, factors are listed here. 2 times 3 is 6. 1 times 6 is 6. 3 times 15 is 45. 9 times 5 is 45. And 1 times 45 is 5. Or sorry, 45. Excuse me. Okay. We do know that they do share one. They do share 1 and 1, obviously. That's not the greatest common factor. In this case, 3 is the greatest common factor. So if I take this 6 and divide it by 3, and take 45 and divide it by 3, I get 2/15. 2 and 15, 2 is even, 15 is odd. You cannot divide an even by an odd evenly. So therefore, it becomes 2/15. Okay, so that is your quick review of multiplying fractions. All right, so now let's move on down to independent events. Okay, independent events is when the outcome of one event does not impact the outcome of another event. That means the events are called just independent events. Okay, they're separate. All right. So, flipping a coin is not impacted or does not impact the outcome of rolling a dice. Okay. Um, just like the dice does not impact the outcome of flipping a coin. Flipping a coin is either heads or tails, right? Rolling a dice, you get 1, 2, 3, 4, 5, or 6. One of those events does not impact the outcome of the other event. Okay. That's where we get independent probability from. So the way we can outline or even determine the probability of an independent event, okay, would be by multiplying the probability of each event happening, or in this case, the probability of A multiplied by the probability of B. Probability of A could be rolling a dice. Probability of B could be flipping a coin, okay, or picking a number out of a bag or something like that. Number out of a bag, excuse me. Something like that would work, okay. All right, so let's go over an example. We're going to look at 4 problems. Okay, we're going to look at a deck of cards. Okay, these cards are emoji, have like emoji faces on them. Okay, so in a board game, students draw a card, replace it, and then draw a second card. So we have 1, 2, 3, 4, 5, 6, 7, 8 cards total. Okay, all of which had different emoji faces on there. We have an angry emoji, we have a sleepy emoji, we have a heart-eyed emoji, and an angel emoji and a laughing, crying, laughing face emoji. Okay, so we're going to pick a card, look at it, replace it. I mean, I put it right back in the deck. So I start with 8 cards, draw one out, I put it right back in there. For my next event, I still am working with 8 cards. Okay, so we got to determine the probability of each event. Okay, so the first event, to earn 50 points, a student must draw a heart-eyed card and then an angel card. So we got to find the probability of drawing a heart-eyed card. Well, look here. Probability of drawing a heart-eyed card, we have 1, 2 of those cards out of 8. So your probability would be 2 out of 8. Okay. Then we have the angel card. The angel card we have appears only have 1 out of 8. So we're left with 2 out of 8. Okay. So we're left with 2 out of 8 times 1 out of 8. Okay. Just like multiplying fractions, you just multiply straight across. 2 times 1 is 2. 8 times 8 is 64. So we're left with this right here. 2 out of 64. Okay. This does simplify. Okay. 2 out of 64, 2 and 64 are both even numbers. They do share 2 as their greatest common factor. So if I divide top and bottom by 2, I'll get an outcome of 1 out of 32, or 1/32. So the likelihood of this happening is not very likely. Okay, I'll describe that as being unlikely. Okay, so that's pretty much the probability of that. Okay, all right. So let's look at the next one here. To earn 20 points, a student must draw a sleeping card and then draw an angry card. Okay, again, these two events are not affecting each other. We take one card out, we put it back in, draw another card out. Okay, the first card happens to be a sleeping card. How many of those we have? I'm assuming that the ones that are catching Z's right here are the ones that are sleeping. So you have 1, 2. So 2 out of 8. Again, kind of like the first one there. 2 out of 8 is going to be the first probability, okay, of drawing a sleeping card. Now, the probability of drawing an angry card, I'm assuming this right here is going to be the angry one. Okay, so 1, 2. Okay, so again, 2 out of 8. So I'm left with 2 out of 8 times 2 out of 8. Okay, so 2 times 2 is 4. 8 times 8 is 64. Now I must simplify this. Okay, 4 and 64 do share a common factor of 4. This becomes 1 out of 16. Okay, still an unlikely chance of happening, but this does have a greater chance of happening than this right here than this right here. Okay, this is more likely to happen than this right here. This is least likely to happen. All right. Number 3, to earn 15 points, a student must draw an angry card or a laughing card. That is one event, and then an angel card. That is the next event. So I need to combine these two cards here. Okay. So you got to figure out how many angry cards do I have? Well, I determined that a minute ago. I have 2 out of 8. Or a laughing card. You see, or you add them together. Angry card or laughing card. So I have 1 crying and laughing emoji. Okay, so that is going to be 2 plus 1 or 3 out of 8. All right. Now, we're going to multiply that by the number of the probability of drawing an angel card out of this deck. Well, it looks like there's only 1 angel card out of this deck, right here on the far right. Okay, that is going to be 1 out of 8. So the probability of this happening would be 3 out of 64. 3 is odd, 64 is even. You cannot divide those right there and get a pretty much an even outcome. Okay, so that's as far as you're going to go. 3 out of 64. Okay, not a very good chance of this happening. Okay, and our last example before this video ends is going to be to earn 5 points. A student must draw a sleeping card or a heart-eyed card. Okay, again, kind of like number 3. So you got these two right here that are going to be tied together, and then an angry card. Well, a sleeping card, we have 1, 2 of those, and then a heart-eyed card, we have 1, 2 of those. So initially, the probability of that will be 4 out of 8. But to make things easier on me, I'm going to go ahead and simplify that to 1 out of 2. Okay, 4/8 is just 1/2. We're going to multiply that by the probability of drawing an angry card. I have 1, 2 angry cards out of 8, so 2 out of 8. This is going to leave me with 2/16. Now, this does simplify. 2 and 16 do share a common factor of 2, so 2/16 now becomes 1/8. Number 4 is going to be the most likely event to occur. Okay, it has the highest chance of being completed. This has roughly a 38% chance of happening. This has roughly, I think, about 7% of this happening. Okay, so again, independent events do not affect each other. Okay, the drawing of a card does not affect the drawing of another card. In this case, we take the card, we take it out, we replace it back into the deck. Okay, nothing has changed. Nothing has been. Nothing. The deck is not. The size of the deck is not changing. Okay, so again, independent events are not affected. Do not affect each other. I hope you guys enjoyed the video. Like it, comment if you got any questions. Hit that subscribe button if you have not already. And I will look forward to seeing you soon. Thanks.